Let's learn another problem today. So in the last videos we learned very easy problem using two techniques. It's a two-pointer techniques and hashing. So let's learn another medium level problem from leetcode where we are going to utilize two-pointer and hashing both together. So let's understand the problem first. So this is similar to sum problem. It's a three sum problem, but there are a few more requirements here. So this is the problem statements. It's saying, given an integer array nums, return all the triplets num I, num j, k, such that I not equal to j, I not equal to k, and j not equal to k, and num I and num j, num k equal to 0. So if you see, the input here, from this input, we need all the number combinations that equal to 0. So that means, here 0 is our target. It's very much similar to two sum problem where the target was something else, some other number, but in this scenario target is 0. So we have to find that number. And what does this means? I not equal to j, I not equal to k. That means, when we get the output, this output set should not have duplicate list things. So if you see here, -1 1 -1 -1 2, it's all if you add all these numbers it becomes 0. But if there is another combination, something like -1 and 2, and this -1 goes at the end, we should not consider, because that looks similar. So how to solve this problem? So let's see how to solve this. So I'm just move this to another screen. Yeah, so the brute force solution is, you can have like the for loop, one for loop here, another for loop here, and third for loop, and you can have logic like this. So in the first for loop, you can start with this. You can say I equal to 0, and we can fix I here, and then you can iterate other numbers and find this, like take the second number, third number, fourth number, and then in a last for loop we can start with third number. So the first number, second, third, and you can try all the combinations, and whenever we get the sum is 0, then in that case add that in a result. So that is the brute force solution. We can do that easily. But if you see, there are three for loops, so that means, it's when we talk about time complexity will be big O of n q, because there is a three nested for loop. So if you use the two pointer technique, then in that case we can reduce this for loop. So let's try in that, like how does that work. So in that case, first thing is we'll iterate with one for loop, like the outer for loop, and we can fix the I to 1, and in that way we can move to the end. So, and this time, like, even we do not have to move to the end, because we are adding three numbers and just trying to find the sum is equal to 0 or not. So if you move I one by one and I reach here, then we can take this number and this number. So in that way we do not have to move I till end, we can move the I till here in this place. So in that way we'll fix a one pointer here, that is I here, and then we can utilize two pointer in rest of the numbers and try to find this sum of these all three numbers equal to 0. And if you find, add that in a result, and we'll continue, and we'll get the final result. But the thing is, when we get the result, we have to sort that result and store in a set. So in that way, if you find the result and store in a set, then in the second time if you find another duplicate result, so that will be that will be ignored. So in that way, in that way we can make sure that we are getting the unique result. So let's see the code, and we can understand better in the code. So this is the num is input. So our answer, let's define the answer. Okay, that's going to be our answer. Return this answer. Let's define a map for storing the unique set. So it's a map, and here we are going to store the three numbers, that is as an array. So I'm defining this array as a key, and the value can be anything. So for now we do not care about the value in this, so I'm going to define empty struct. Okay, so map is declared. Let's create another for loop. So I less than the length of answer -2. Yeah, we do not have to iterate till end, so that's why -2, and then I plus. Now here we fix two pointer. One is left and right pointer, or we can say j and k. J can be left pointer, k can be right pointer. So j will be I plus 1, and the k is always going to be end. So that is length of this is not the length of answer, this is length of nums. So length of nums -1. Okay, so in this way we fix this two pointer. One is at the beginning and one is at the end. Before that, in order to proceed with this two pointer approach, we have to sort the numbers here. So let's sort it first. Sort ints nums. Okay, it's nums sorted. Now we have like two pointer we have declared here. So this is one for loop, and that's another second for loop. And here we can say j less than k, and we can, in this case, we can sum the number here. Like, so sum here is nums I plus nums j plus nums k. So we sum like all three numbers, and we are checking if sum here equal to 0. That means we found the result. So let's define the result here. So that's a result. Result is int, and we know that this is going to contain three numbers, so that's the array, and nums I comma nums j nums k. Okay, we got the result, and now we have to sort this result so that we can store the sorted result in a map. So in that way, if you get the duplicate, that can be ignored. Okay, so sort this, sort ints, and it's a result. It's sorted, and then we can add this result to our map. So it's a map result, and that's a result as a key, and the value is the empty struct. We do not care this value. Okay, so we got we got the result. In the case we got the result, we added this and then we just move uh, j j pointer. So else, and in the case in the two pointer approach, if you see, this j is less than, or not a j, but let's say sum here less than target, and our target is 0 here. So in the 2-point approach, if the sum is less than target, then we move the left pointer, and our left pointer here is j. It's a j plus plus, else k minus minus, and in other case decrement the pointer, that right pointer. So in this way we'll get the result here. So now our result is added to m. Now get all these arrays from list, from this hash set, or we say the map, and store that to the answer. So let's do that. So I'm going to iterate this map. Keep we do not care this value, so just underscore and range map, and then okay, so that's the key, and I'm going to add answer append answer and key. So let's run this. Sort ins result. Okay, so whenever we need to sort this array, then we have to use this way, like use the result, and then line number 28, answer append k. Okay, what is the answer? Is int, and what is this? Okay, so we can utilize same approach here. Let's try now. Okay, that's good. Let's try to submit. Yeah, so that's good. So this is utilizing the 2-pointer technique, and as well as hashing also, and based on that we got the result. Let's see the Java solution. So I already tried this Java solutions. Let's find this. So Golang. Okay, so for the Java, it's the same approach here. I sorted this nums, and the nums is array, so that we need this function to sort. We define the hash set, or it's just a set to store the unique result, and this set is a list of integer. We found num len, and there's an outer for loop, and then we have defined two pointers, one left pointer and a right pointer. J indicates left and k right pointer. Same logic here, while j less than k, and calculating sum here equal to 0, then that's a result. We sort the result and then store to the set j plus plus, else if. In this case, like you can, even though you can move left pointer, or if you want to decrement right pointer, that's fine too, because we found the result, and in any way it works, j plus plus or k minus minus. But in this case, in sum here less than 0, that means we need bigger number, move the left pointer, and other case move the right pointer, decrement the right pointer. We got the result, and you are getting that data out of the set and storing to the result, that is the list, and at the end return the result. So this is the Java solution. So it's the same approach. So that's all for today. Thank you.